Hello everyone. How are you guys doing today? I have your exam, but I'm going to give you at the end. Not now. So how are you guys doing today? Is there anybody who's still facing my method issue? So everybody is okay with my method now? My method?
So I did the first two chapters of homework, but it didn't save.
It will be transferred. So that problem, I received an email from the department yesterday. I don't know whom he replied, someone he replied, and he said that transfer from old MyMathLab to the new MyMathLab, all the grades, they're still doing that. So it might take a little bit time.
So if I did
Once you did your homework, it's saved.
It's saved. Because you can't do the quiz without finishing homework.
Also, I posted, I assigned 4.5 next week Monday, and we started 5.1. So section 4.5 and chapter 5, I said the deadline next week Monday, and I forgot that tomorrow, Thursday, we didn't have any class. So definitely we'll not able to finish everything today. Chapter 5, whatever we do today, I'll change the due date next Monday for that sections, or that many sections. Okay, I just remembered, we didn't have any class Thursday. So let's see how much we can finish today. Do you guys remember your exponent rules from yesterday? So what happens when you have two powers together? Like 7 to the 4, whole thing is to the power 5. We multiply the power. Two powers together, we multiply. So we get 7 to the 20.
That's the power.
How about the next one? We have more things on the base, so we distribute everything on the base. So 8 to the 9 times 6 to the 9. How about the division? What do you see 4 times 9?
No, I'm saying, what it was parentheses 8 times 6, so that the power parentheses 9.
So we're going to do the multiplication first. But the purpose behind these questions is to apply the power rules, the exponent rules. So that's why instead of multiplying 8 times 6, we're just distributing. Or let's make your life easier. Let's say this is x. So you cannot multiply anymore. It's 8 to the x, 8 to the 9, and x to the 9. Power rule. How about division? What do you do in division? Distribute. Still, we do the same thing. Whether it's a multiplication or division doesn't matter. If your base has more elements, then you have to distribute everything, distribute the power to everything on the base. And I'm not simplifying here because all these numbers are big, too big. And then we have base multiplication. There are two same base, we are multiplying them. We keep the base, but we add the exponents, so we get 5 to the 15. Now comes the division. What do we do with the division? Subtract the power. And then there are two scenarios. Either the numerator is bigger or the denominator is bigger. So for the first one, which one is bigger, numerator or denominator? So we keep the denominator and we subtract the numerator power. What goes in the numerator then?
1.
Great, 1. So 1 over 9 square. And this small number, we can go further. 1 over 81. So let's see. How about the last one? Our numerator is bigger, so we keep our numerator power and we subtract the denominator power. So we get 9 square. So it's a whole number 81, not a fraction 81. So when the denominator is bigger, we get a fraction. When the numerator is bigger, we get a whole number. And these are 7 rules you learned yesterday. Any question from anything here?
Do you have to keep it as equal or can I put times square in?
For smaller number, you always have to simplify. For bigger number, like the left page, they're too big. We can't do anything, so you have to leave them alone. If even 5 to the 15, it's so big, we don't know. But square or cube or fourth power, they're small, so you should expand our distribution. Marvelous.
Quick question. Can you quickly go over the minus? This is minus x squared.
Negative. Negative and then?
Negative x, but both in brackets.
Square. Since you have a parenthesis, that means everything inside the parenthesis is your base. So you have two choices. Either you rewrite as negative x times negative x, or you can distribute the power. If you do distribute the power, this is same as negative square and then x square. Negative square means you're multiplying negative twice. So what do you get? Positive. So it's positive x square. Same thing here. Negative times negative turns into positive. X times x turns into x square. So you get the same result. So anytime you have anything inside a parentheses, you can always distribute the power. That's why we did this. 8 and x we have inside the parentheses, 2 and 3 inside the parentheses, so we distributed. Okay, more rules. What is anything to the power 0?
1.
Great, 1. Except 0 to the 0. What is 0 to the 0? DNA, it doesn't exist. So, any positive thing, any negative thing, any variable, any number, any decimal, any fraction, anything. If your power 0, the answer is 1, except one case, 0 to the 0. When you have double 0, the answer is undefined. We don't know what that is, 0 to the 0. And now 1 to the any power. 1 to the negative power, 1 to the positive power, 1 to the fraction power, 1 to the decimal power, 1 with anything. What is that? 1. So 1 is the most generous number. It doesn't have problem. What's wrong with these two? Now comes its cousin, -1. -1 has two things. It gives us one result when you have odd power. It gives us another result when it has an even power. So what do you think? -1 to the odd power? -1. For example, -1 with the 1, it's same as -1. -1 with 3, it means you're multiplying negative, negative, negative. It turns into negative. So negative, if you multiply odd many times, the result is negative. And how about even power? If you multiply negative any even number times, positive. For example, here, negative with the square, see, it turns into positive. Same thing, negative with the 4th power, it will turn into positive. Negative with 6th power, 8th power, any even power, it will turn into positive. And any power means a whole number, okay? Not fraction. For fraction, there's a different scenario. I should write odd power or odd fraction. Odd power or odd fraction is same, but for even we cannot write even fraction. If you have a -1 with an even fraction, it becomes unreal. It becomes imaginary. I should write this down here. -1 with even fraction. Yeah. Later, we are going to learn that if it is square, -1 to the 1/2 power, it will turn into I. But -1 with 1/4 power doesn't turn into I. It turns into something different. Huh? Even fraction. DNE. Which one? Doesn't exist. Does not exist. In other words, undefined.
So how do you get from -1 to even 2
Why do you see even 2?
as the answer of the bracket?
This is not 2, this is 1. This one, right?
Oh, we got, oh,
It's 1. And I wrote fancy 1. It's one simple one. So if you have -1 to the even whole number power, it's 1. But if it's even fraction power, it doesn't exist. We are going to learn more about fraction power later. But for now, just remember, even power, even whole number power does exist. It's 1, but even fraction power doesn't exist. So -1 is a special number. Not only -1, any negative base. The main thing is negative base. Negative base with odd power, the answer exists, it's negative. But negative base with even whole number becomes positive, even fraction doesn't exist. And then we have our special 0. We already know 0 to the 0 doesn't exist. How about 0 to the negative number? Now, before even going to the negative number, how about 0 to the positive number? For example, 0 square. What is 0 square? 0. What is 0 to the 3? Still 0. What is 0 to the 4? 0 times 0 times 0 times 0, still 0. What is square root of 0? Still 0. So 0 with any positive number, what's the answer? 0. So 0 to the 0 doesn't exist, but 0 to the any positive number, positive whole number, positive fraction, positive decimal, anything with the positive is 0. And now the negative power. For example, let's say we have 0 to the negative 2. Negative means it's a fraction. Negative power means a fraction. So this becomes 1 over 0 to the positive 2, which is 1 over 0. What is 1 over 0? You have one pen, and I'm telling you to divide that into 0 pieces. Can you do that? We cannot divide anything into 0 pieces. You already have 1. Can you divide it into 0 pieces? So, what's the answer? Doesn't exist. We don't know how to do that. We don't know how to divide anything into 0 pieces. Dividing by 0 means break this down into 0 pieces. So we cannot break anything into 0 pieces. So the answer is doesn't exist. So 0 is a special number. It cannot take 0 as power or negative as power. The only thing it can take is positive things, positive number. So it's the most positive in this world. It doesn't allow any negativity or any 0 next to that. So 0 with positive number is 0, negative number or 0 doesn't exist. So these are the rules for 0, 1, and negative 1. Any question? No. Let's do some example. 1/2 to the 0 power. Who would like to try that? Really? What is any positive thing to the 0? 1. Getting wrong is perfect. That means you're learning. We learn from our mistake, but if you never make a mistake, that means there's a high possibility of not remembering that in future. Oh, it just got broke. How'd you get broke? Wow. Okay, who would like to try B? Eliza. -4 to the power 0 is still 1. Anything to the power 0 is 1 as long as it's not 0. How about C? Who would like to try C? Still 1. It doesn't matter what is our base, as long as our power is 0, the answer is 1. And if the base is not 0. How about D? X over Z, whole thing to the power 0. The next one is not one thing, it's two things. One is -9 and one is x to the 0. So between -9 and 0, we have a multiplication sign. So before multiplication, we have to apply the power. So -9 times, what is x to the 0? 1. And what is -9 times 1? -9. So when your base doesn't have any number, it has a number outside of the base, you have to multiply that number with your something to the power 0. In other words, exponent comes first and then multiplication. Okay, now comes a combination of all the rules. Rule number 1, we have more elements of the base than 1 power. What do we do with the power? Good job, distribute. So we distribute, let me get a new page. Let me know when you're done with the last one. I have to flip page twice. Are you guys done with the left page? Okay. Come on. Okay, give me 1 second. I have to reset this. Save. Now, so step 1, distribute. We have 1, 2, 3, 4, 5 things inside our base. So we are going to write 5 of them with their individual power 4. So we have 3 y to the 5 negative 2 x cubed. Well, you can think negative 2 is one thing. So 3 to the 4, this to the 4, this to the 4, this to the 4, and this to the 4. Everything gets the 4th power. So 3 to the 4. Means 3 times 3 times 3 times 3. What do you have? 3 times 3? 9. 9 times 3? 27. And now what is 27 times 3? This is another thing you have to remember. It's 81. 3 to the 4 is 81. 3 times 3 times 3 times 3. So this gives you 9. This gives you 27. And this gives you 81. So first one, we didn't have to follow any special rule. But how about the next one? We have y to the 5 whole thing raised to the power 4. 2 powers together, what do you do, Martin? Multiply. So y to the 20. Eliza, what do you do with negative to the 4? It means you're multiplying negative 4 times. Negative to the 4 means negative, 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 negative. See the rule here? If you multiply negative even times, it turns into positive. So negative to the power 4 means positive. 2 to the power 4. 16. 2 times 2 times 2 times 2. And lastly, 2 powers together. What do you do? Multiply. Can we simplify anything? Let me write here. This is my question. Can you reduce anything? Can you simplify? For variable, can you reduce? Can you do anything? One of them is y, one of them is x. Can you do anything? all those rules we had before, their requirement is our base has to be same. Here we have y one base, x another base, so you cannot touch x and y. Now, if you're looking at 81 and 16, can you divide both of them by any number? 8 doesn't go to 81. 8 goes to 80. 81 is even odd number, so you cannot divide by 2. No, only the numbers. The exponent we cannot touch because exponent is based on the base. So x to the 12 and y to the 20, we cannot touch them because their bases are not same. And 16 and 81, one of them is odd, one of them is even. They're perfect squares, but they're not divisible by any number. So you have to leave them alone. Any question on this one?
For the bottom question, we put -2 distribute the board.
So if you don't want to do this, you have another choice, -2 to the 4. It means -2 times -2 times -2 times -2. It will turn into a positive 16. Now comes next one. Change this. And then I think I have one more. So try these two for 2 minutes. Let me take that 10 minutes now. Today is 6/7. Brandon, not here. Liliana, Martin, Christopher, Axel, Matthews, Eliza, Angel, Handa, Maria, Ashley, Agnosa, Exona, Jason, Kathy, Asim, Kayla, Chriselle, Calisius, Mariam, Bennett, Hey, Chanel, Jasim. Oh wow, hey, that's not Jasim. John. Ready? No. Let's do it together. Tell me, what do you have? It's okay, I'll help you. So we have P's and Q's. So p to the 5 minus 2 on the numerator. Great. And then p3 or you can simply write q on the denominator. So denominator is bigger. Sorry, it's 6. So you don't have to write 1 over. We have two variables p and q. One of them goes on the top, one of them goes on the bottom. P goes on the top because p has a higher power, and q goes on the bottom because q has a higher power on the bottom. So at the end, 5 minus 2 is 3, and 8 minus 6 is 2. So q gets 2 power on the bottom, p gets 3 power on the top. That's it. It's fine. So what you did is this p cube and then 1 over q square, right? But then remember you have to multiply. So when you multiply the top. So you end up getting p cube over q square. So Jannah is here. Any question on this one? Who would like to try the next one? Jason.
Combine like terms by multiple exponents, so
Mhm.
x12, y9, and z to the 3.
How do you
Wait,
get
wait, wait.
x12? So we have an x term here. Do you have any x term in the first term?
Oh, my bad.
So there's only one x, so I keep it. But your idea is perfect. You have only one x term, we leave it alone. Then we have two y's. So y to the 7 and y square. And then we have two z terms. So we have z to the 7 and z cubed. So x to the 5. How many y's we have? 9. And how many z's we have? 10. So exponent rules, when you have same base, you add the powers. Your idea is okay? Any question?
We have to find the other term for y. So that would be like y is 7 times x to the 5, and then plus y to the 9.
Do you see any plus sign given to you here? Then how did you get the plus sign? If you are not given any plus sign, you cannot get any plus sign. So what you're saying is, if you have this, then you can distribute. But you're not giving any plus sign, so you're not distributing, you're combining. So if you don't see any plus sign or minus sign, it's not distribution. It's just combination. You're combining your powers based on the base. But if you have a plus or minus, that means you have to distribute. So you're going to learn plus and minus later. But for now, it's just combination, combining powers. And now comes homework question. You have a rectangle, and instead of giving you the length and width with the numbers, they give you numbers and variables. And they are asking you to find the area of this rectangle. So question number 1. What is the area of any rectangle with length L and width W? Length times width. So let's say this is length and this is width, or vice versa, it doesn't matter. So what is the area of this rectangle? 7x cubed feet times 9x to the 6 feet. So you're multiplying length and width to get the area. 9 times 7, 60 what? 62? 3. 63. And x to the 6 times x cubed. X to the 9. And then we have feet times feet is feet square. In other words, this is 63 x to the 9 square feet. That's why every area has a square in it, because you're multiplying the individual unit twice. For example, square inches, square meter, square centimeter. So every area has to have a square in it because of the multiplication. Any question? With this, you're done with section 5.1. So next Monday, you have another homework, 5.1. Five point one goes with 10.2. So I'm leaving 10.2 till the end. 10.2 is more exponentials. So far, whatever you learned, have them in your brain. Memorize them very well. So the rules we learned, 5 rules from yesterday, and this is the new rules we learned. So 5 and 8 of them here, including this one. So 5 and 8, 13. 13 rules, make sure you remember very well for now until this semester over. And now we are going to do something different than all those rules. But we are going to use some of the rules in here. So we are going to do 5.234. These are a little bit easier and kind of fun than 10.2. In these 3 sections, we are going to learn about polynomial. How do we add them, simplify them? How do you simplify them, add them, subtract them, multiply them, divide them, those things. So they're easier. So before we go to the polynomial, we have to know a few things, like what is a polynomial. So polynomial is a finite sum of terms in the form of a times x to the n, where n is a real whole number, integer, not integer, sorry, whole number, natural number. If you have a fraction, it's not a polynomial. If you have a decimal on the power, it's not a polynomial. If you have a negative power on the power, it's not a polynomial. So the only thing a polynomial can have on the power is a positive whole number. For example, the first one, 2x to the 5 minus 3x squared plus 1. If you look at the power, the first one is 5, second one is 2, so it's a polynomial. The bottom one, x to the negative 5 minus 3x to the negative 2 plus 1 is not a polynomial because of the negative sign. Even if your one term has a negative sign, still it's not a polynomial. It becomes something different. So in order to be a polynomial, we cannot have any negative power on any term. Now, in a polynomial, we have 3 special things: the degree, the leading term, and the leading coefficient. Degree of the polynomial means the highest degree you see, the highest power you see in your polynomial. So for example, here we have x to the 4 minus 3x to the 20 plus 7. The 2 powers we see is 4 and 20. Which one is bigger, 4 or 20? 20. So the degree of this polynomial is not 4, it's 20. Degree means the highest power. what is the highest power you see in a polynomial. Now, whatever term contains that highest power, we call that term is the leading term. Even though our middle term is the leading term, but still the first term is not the leading term. The middle term is the leading term because the middle term has the highest power. So the entire term, negative 3x to the 20, the entire term is called the leading term because of the highest degree. And the last thing is the leading coefficient. So in your leading term, whatever coefficient you have, it could be positive, could be negative, could be decimal, could be whole number, could be anything. That number with the exponent is called the leading coefficient. So in this term, negative 3x to the 20, what is your coefficient? Negative 3. These three things are the most important thing in polynomial. Why? Because that thing determines what's the end behavior of the graph. We're not going to learn that here, but in pre-calculus, we're going to learn that if you're taking pre-calculus. Based on the leading coefficient and the degree of the polynomial, you can draw a graph without even knowing anything in the middle. Any questions so far? Okay, now we are adding and subtracting. When we add and subtract, we look for the same power. As long as they have the same base with the same power, we can add their coefficient or subtract their coefficient. So like terms means they have the same base and same power. Their sign could be different. We don't care about the sign. The only thing we care about, do they have the same base with the same power? For example, here 5y squared minus 11 minus 3y squared plus 9. What are the like terms we have here? Because we have y squared and y squared. Both of them have the same base y with the same power square. So when you have the same base with the same power, you keep that and add and subtract their coefficients. So we have 5 coefficients and negative 3 coefficients. What do you have? 2y squared. And then these two are like terms because they're just plain numbers. Negative 11 plus 9 gives you negative 2. That reminds me of your exam. In the exam, surprisingly, almost half of you didn't get the slope question correct. The slope question was find the slope that goes to the 2 points, which has negative 2, negative 3, negative 11 on the top, and 5, minus 5 on the bottom, and you have something like 11 minus 3. Do you remember this question? Okay. So it should be easy. Surprisingly, most of you got the numerator correct. And what did you get from the denominator? Only a few of you got negative 10. Guess what the rest of you wrote in the exam? Wonderful. See? Many of you wrote this is 14 over 0. As a result, this is wrong. So the question below that, you got it wrong. It's definitely not 0 because when you have same sign, remember, same sign means adding the number. So it's not 0, it's even more negative. It's negative 10, not 0. With the power. Because all those exponent rules are either for multiplication or division. We did not have any rule for addition or subtraction. If you look at all these rules, all these examples we did, see, multiplication, division, multiplication, division, division. Do you see any addition and subtraction anywhere here? So addition, subtraction doesn't have any power rule. Only multiplication, division have. So here, it's definitely not 2y to the 4. It's 2y square. You keep your variable portion same, add and subtract their coefficients only. So this is 0. The next one from the homework. It's a subtract that from the sum of those. What does sum mean? Add. So if you're subtracting that quantity, it means it's minus 9y squared minus 2y minus 2. Sum of these two. What do you have to do with these two? What do you have to do with this and that? Add them. So 7y squared plus 1 plus 5y squared plus 8. In addition, we don't have to use parentheses, but in subtraction, we have to put parentheses. So sum means sum. And subtract means you're subtracting. And you're subtracting more than one quantity, so we have to put parentheses around whatever we are subtracting. Why do we have to put the parentheses? Why can't we write it without parentheses like the plus?
Because we have to multiply minus.
Good job. You have to distribute the negative to everything inside whatever you're subtracting. So we have 7y squared plus 5y. These two are like terms, so we can combine these two. And then you're subtracting 9y squared plus the 2y plus, so this is minus 9y squared plus 2. Because of the minus outside, every sign you have inside will change. That's why you have to put parentheses. Any questions so far? No? Okay, tell me what like terms you see. Seven y squared minus 9y squared. How much you get? Negative 2y squared. Anything else?
Plus 7y.
5y plus 2y. So we have 7y. Anything else? Plus 9 plus 2. So plus 11. Can you combine the negative 2y squared with 7y? No, because they don't have the same power. We are only allowed to combine whatever has the same exponent, same power. Any questions so far? So this is easy. You try this one, and then we are going to the multiplication. And you'll have this in the exam. Not the same question, but similar. What time is it? 2:51. Ready? Based on the exponent, you combine the coefficients. Coefficient is the number in front of the variable.
The exponents don't change that.
You want to try it? Okay, tell me what to write.
What did you say?
Tell me what is supposed to write now.
Oh. 2x.
2x squared plus 7x minus 9 plus 2x squared minus 8x plus 1 plus 4x squared cubed plus 17. So distribute the negative from the outside. So every sign you see inside, whatever you're subtracting, will change. And now comes the like terms. What like terms you have? Eight x squared. And then negative 1x, 1, it can be invisible. Negative 9 plus 1 plus 17. Positive 9. Negative 9 plus 1 is negative 8. 17 minus 8 is 9. Is anybody who has different answer? If you do, I will help you. Nobody has anything different?
Yeah, I did. So I just didn't combine the signs, so I have negative 8x squared. And then,
Negative 8x squared.
and then I combine. So I combine the 7x and the 8x. So I thought it was there, could be squared.
So 7x is positive, 8x is negative. Anytime you have two different signs and you're combining, you keep the sign from the bigger number. So bigger number is 8. Whatever sign 8 has, you have to keep it, and then you subtract. 8 minus 7 is 1 with the variable.
And then I just found.
So yes, it's a common mistake with different signs. So if you add plus and plus, the answer is plus. If you do 2 minus, the answer is minus, but actually you are adding them. You keep the same sign, negative, but you add the quantity you have. And then as long as you have 1 plus 1 minus, you always subtract, but the sign, it depends on the bigger number. Whatever sign you have in front of the bigger number, you have to keep that sign, but you always have to subtract the quantity. So these are the 3 addition rules. Add to plus minus is plus. Add to subtract minus numbers, it's a minus number, but you're taking their sum. And then 2 different signs is always subtract. So with this, we are done with 5.2. So we have another homework. So far we did 4.5 homework. 4.5, 5.1, 5.2. And now we are going to do 5.3. Adding and subtracting polynomial is 5.2. 5.3, you're talking about multiplying and dividing, I think. Polynomials, but only multiplying polynomials. So multiplying polynomials, we have to use our exponent rules. In multiplication, what do we do with the powers? We add the powers. So in addition subtraction, we did not add the powers, we added the coefficients. In multiplication, we have to add the powers also. So when you multiply polynomials, we multiply numbers with the numbers and multiply variables with the variables. When you multiply variables with the variables, you have to add their powers. For example, here we have -6 and 5. These two are like terms because they're numbers. So you multiply -6 times 5. And then we have the variable portion n cubed and n to the 5. So say in multiplication, we add them. So the answer is n to the 8. And when you multiply -6 times 5, -30. So previously we added the coefficients, but left the power alone. Now we cannot do that. We need to multiply the coefficients, also add the powers. It is a multiplication. Exponent rules. Power rule. So we have one term times one term. So we call them monomial. One term is monomial, two terms is binomial. So in the next example, we are multiplying a binomial with a monomial. What do you think the first step is? Distribute. So saying now you see a plus sign. So you have to do the distribution. Previously, you couldn't do that because there wasn't any plus or minus. So we have -4x times 9x to the 4. You're multiplying -4x times 7. And then you multiply numbers with the numbers. So -4 times 9. And then x times x to the 4. Here we have 4 times 7 and then a single x. This line is extra, you don't have to write once you understand the process. From the second line, you can directly write the fourth line, what we're going to write now. So what do you get from the third line?
From -36 to the 5.
-36 x to the 5.
X to the 5 minus 20.
Minus 20, yes. Minus. Exponent rules. In multiplication, what do you do with the powers? Add them. So this one has invisible 1. So you get 1 plus 4, which is 5. So even though you multiply or divide, you still have to combine the coefficients and observe the powers. In addition, subtraction, we only observe to change them. But in multiplication, we use the power rules, the exponent rules we learned to combine them. And now, this will be in the exam. And this also final exam. At least one of the multiplication you'll have in the final exam. So first step, you distribute your 4x, you're multiplying entire 6x squared minus 5x plus 2, and then -3. So you have -3, and you're multiplying entire 6x squared minus 5x plus 2. So it becomes same as this one. And then you distribute more. 4x with 6x squared. You have -5x, so you do 5x times 4x. You have 2 with the 4x. In the next one, you have -3 with 6x squared, -3 with 5x, and lastly, -3 with the +2. And then you do the exact same thing what you did here. Multiply the numbers and add the powers for the variable. So 4 times 6, 24. X times x squared. X cubed. 5 times 4 is 20. X times x is x squared. Here we have only numbers, so 8x. -3 times 6. -18x squared. Plus or minus. -3 times 5x. -15x. Plus -3 times 2. -6. So multiply the numbers, add the powers for the variable. So as you can see, there is no more x cubed term. So we have only one x cubed term. Martin. -3 times -5 is perfect. Yep. I missed my negative. So this is positive. Thank you for catching that. So for x squared, we have 20, -20 x squared, -18 x squared. Same sign, what do you do? Keep the sign, but actually doing add or subtract the numbers. Add. So it is 20 plus 18, 38. And here we are adding, so we cannot change the power. In addition, subtraction, we cannot change the power. Only in multiplication, we can use the multiplication power. So multiply means power will change. But here we are combining and adding, so power will not change. We're going to have same x squared. The next one, plus 8x plus 15x plus 23x. And lastly, there is no more number besides 6, so it's -6. So this is how normal people do, usually people do. However, there are other ways of doing it. For example, many people they like the box method. Like you draw a box and then you multiply. They found this easier. So let me show you one box method. Let me show you the same one box method. So we have 4x and -3. And then you have 6x squared minus 5x plus 2. So you put them inside boxes, and then you multiply them individually. For example, multiply this, and this. So 4 times 6 is 24, x times x squared is x cubed. Negative 3 times 6 is negative 18, and there is only one x squared, so x squared. And then you go to the next box. This times this, and this times this. So 4 times negative 5 is negative 20. X times x is x squared. Negative 3 times negative 5 is positive 15. And there's only one variable x. Lastly, you go to the next box. So 4x with 2. And this negative 3 with the 2. 4x times 2 is 8x. Negative 3 times 2 is negative 6. And then you combine like terms. Green. Only one x cubed, there is no more x. And then you have 2x squared term. You have 2x term. And then negative 6 is alone. So you just combine their like terms. So the answer is 24x cubed, because this is alone. And you have negative 18 and negative 20x squared. That gives you negative 38x squared. Then you have positive 15 and positive 8. That gives you 23x. And lastly, 6 is alone, so negative 6. So whatever method is easier, you can follow that method. And now you try one. What time is it? 11. You try this. Let me give you an example. What do you have next? Oh, with this we've done it 5.3. So your homework till homework for Monday is 4.5, 5.1, 5.2, and 5.3. For homework. And Thursday we have no class. This Thursday. But tomorrow you have your fields now. Only just Thursday no class. Next Tuesday we have a class. Next week whole class. Next week whole week we have class. And next week you have your exam on Thursday.
You should class with the online.
Next Tuesday class online. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1. So you're going to fill out and your function out.
Yeah, she says, but it's like 3 of the points that are off the best.
This reflection or 3 points. What is the Brandon Taylor Matthews Mariam Michelle Andra so Maria. Remember, even if you didn't do well in the first exam, still you have 4 more exams left. Kitty, K. Jasmine, yes, ML, Exona, Astin, and Jannah. Do I have something? Solution. Right. No, because I actually that's a you have I one with power citizens even power no one
I don't actually. Absolutely up to you.
So what I think
Oh, damn. You. Lower corners?
Actually, we're done here. You have to don't leave. You cannot leave until you give me this. Fill out the reflection, and then you can fill out honestly, especially with the bottom part. I care about the bottom part. The last fill in the blank. If you didn't do well, why do you think you did not do well? And how can you study differently to do better in the next one? Our next one is next week tested. Not asking to. I don't know. The main thing is the bottom one. So here, what do they want to write?
Oh. Oh, one line, right?
Done. That's all.
That's it?
That's it. Remember, Castile, we have no class.